So let's talk about state-based model. Okay, so what is the difference in reflex-based model and state-based model? So as you can see from the previous slide, it is a bit intelligent as compared to the reflex-based model. So how we incorporate the intelligence? Suppose in the previous example, you saw that we have to show in the reflex-based model, we have to comment on whether this is cat or not. Okay, so I have shown you through the linear classifier and I ask you one question to comment on that. Okay, so there is no requirement of any reasoning and all that, and you directly learn what it is. So that is requires very less level of intelligence. But for the state-based model, here for example, if I'm asking you, this is a chessboard, we have white and golden, and I'm asking you what will be the next move of this gold. Okay, so that time what we have to do? You have to take care of all the actions. Okay, what actions you are going to take? What actions is going to take by the opponent? Here opponent means I'm assuming that this other than you, everything is environment. Okay, so whatever steps you are going to take, whatever actions you are going to take, what will be the consequence of the actions, you all have to think. Am I right or wrong? Because when you are playing the chess, that time you have to think of, if I do this, how opponent will think, how environment is going to take it as in positively or negatively, right? How what actions is going to consequences for what? You also planning for, I will do it first and then will thought of to move this to another place. Okay, so there's all kind of actions. So when you are shifting from here to here, somewhere other place, this is called taking actions. And if you are placing from this state to another state, this is called different state. Okay, so that's why this is called state-based model. And why this is different from reflex-based model? Because there is uncertainty involved in that. Am I right or not? Is it making sense? We are incorporating uncertainty as per the environment. We don't know what will happen, right? Because we did the action. Now environment will did some action against you. Am I making sense or not? Right? So you know that what is the action I'm going to take, what will be the consequences. You all have to think these things. So this requires a bit reasoning in your mind. So that makes a difference between this state-based model and reflection-based model that I have discussed earlier. So here uncertainty is incorporated in that system. So let's give a formal definition of that. What is the application? You can easily see that we have used in game chess, and I told you that there is one, I mentioned this about this game Go and this Pokemon. These things I hope you are aware about these games. If you are not aware, just put it on the Google, or you can put it on YouTube and see this, how this Pokemon will work. You have to eat some food and you have to escape from the enemy also. And Go is something we have to, I also haven't played this game Go, but I have seen this on YouTube and all that, how they're playing. Okay, I don't have any my personal experience, but yes, chess, of course, we all Indian knows about this chess game and all. Okay, so here some reasoning is required. Okay, and then robotics. Okay, motion planning. For example, my hand is a robotic arm and I want to put something here. So if my hand is going like that, putting like here, then once I change my hand, then again it has to go here. Then again I'm shifting my hand, so go here. And this shifting of hand may be because of any reason of the atmosphere, any reason of the environment. Okay, my hand is shifting because of someone is pushing me from backside, but this is robot and it has to do. So that's time, if it is shifting here, it has to take care that it has to move like that. So there's a lot of uncertainty involved. in that, because my hand is moving and I don't know where it will move. Okay. So this is a motion planning. Okay, that is a state-based model, because here again uncertainty is involved. Now this natural language generation, just like machine translation. So for example, you all are using some Google Translator, right? You are writing your sentence in English and you try to convert in Hindi or Arabic or Urdu, whatever language you are trying. Okay, so that is our machine translation. Image captioning, right? So if you have an image and then later you got the caption that there is a flower and there is a mountain in an image, right? So this is called image captioning, means you have to describe about the image in the words. Okay, so I hope it's making sense, right? So I told you that this is a state-based model, means you have decided so many things and you have opted one, and we know that whatever you have opted, they're again going to give the again these many uncertainties. Again you have to choose one, then again go, again you have these many uncertainties, again choose one, like that. Just like you have taken a first move in the chess exam, chess board, right? And again you have to think of that what I have to move. There are so many ways to do that in a similar way, like that. Okay. Then we'll talk about types of state-based model. So I already talked about the three types: search problem, Markov decision process, and adversarial game. Okay, so these this actually is in your syllabus, is written. So I hope you are getting that how we can. I will try to introduce with the syllabus through this journey also, that this was in syllabus and this was not in syllabus, because in the syllabus it was written very precise and concise, and this is not mentioned that how it is going to what topics we need to cover. But I told you whatever the syllabus I showed you there, yeah, that is it for the artificial intelligence, all things. Okay, so I will try to cover up all these things, and I hope all the questions will come up in the exam will be from the same topics only. Okay, so just like they have talked about inference. So inference means we'll talk about here also modeling, inference and learning. We'll talk about here modeling, inference and learning. We'll talk about here modeling, inference and learning. Right? And in different methods also. In search problem, we'll talk about modeling, inference and learning. Here and so modeling, inference and learning. So inferencing and incorporate of uncertainty. So uncertainty is involved here also, and here also, because uncertainty involved is actually forcing us to be more intelligent. Right? Why we want intelligence if everything is predefined? If everything is not predefined, that time we want intelligence, because we have to crack that deal for whatever you want to do. Okay.